Now I'll talk about how can you take the dispersion compensation data and why it's happening. The dispersion compensation, you need the dispersion compensation because in the reference arm and the sample arm refractive index is different. If the refractive index in the sample arm path or the reference arm path is different, then you have to compensate those difference by post-processing. So how can we do that? So to do that we have to take data. So the way you can take data is that you can put a mirror in the sample arm and adjust the neutral density power of the mirror so that you can only collect 25% to 30% of the total power. So actually the sample arm, from the sample arm we are collecting the 25 to 30% and 30% of data, and from the reference arm we are collecting the 70 to 75% of the data, and then we are taking the data of interference data. Now there are different parameters, so these are the parameters you need to set. You need to find the peak of your data, and what is your peak, what is the peak threshold value, and some other fixed pattern data, what is your data length, and other stuff. So let's run the dispersion compensation GUI. So I made a GUI just to see how things goes on, and it will be easy to see every steps pretty easily. So we can see different button here. Load button, you can load the reference arm data, you can load the sample arm data, or we can load initial parameters. So let's see what is our data. So this is the data of the noisy data. When we block the reference sample arm just to collect the data from the reference arm, because this will represent the noisy data. And we have collected the data from the sample arm when both the reference arm and sample arm are open. That means we are collecting the interference from the sample. And also there are some parameters, initial parameters we set, but we can check first like what are the parameters we will set. So let's first now load the noise data. You can just do the simple single click, and here is double click. So you have loaded the data. You can look from the dispersion GUI here, it's loaded or not. So let's load it one more time. So you can see it's loaded. You'll see from the command window that it's loaded or not. Then we load the sample arm data, single click, and the sample arm, double click, and we load our initial parameters, and our initial parameters file is here. So we are loading all these things. Now we have to correct the MGI peak info. So click here, it will run for MGI peak info. Let's see what's coming out. So this is the raw MGI file. So we can see this kind of interference data. The usual data, if you look at the usual data, is up to 2000 points, because when the wavelength laser source is sweeping from the low wavelength to high wavelength, actually we are acquiring data for 50% of the time, and another 50% of the time the laser wavelength will come back to initial points. So basically the usual points is the 50% of the data. Now if we clean our data, this is the clean version of the data. That means we have removed all the data that's unnecessary. That means when we are not actually sending any wavelength, when we are just when the laser is coming back to initial position. So These are those data, and this is the depth profile. And for this depth profile, we have to set some parameter. We need to check the peak. What is the peak? For the peak detection, we have to select some initial range. We can select here like what are our initial peak range, 50 in the x-axis to say 600, 700, whatever. Then we have to select some SNR threshold. Say we can set here, say SNR threshold for the peak detection is 88, and also in the right side we can select the same type, 88, 87, whatever you select. These are important. So that's stage 1. Now you can do another type of thing is you have to select the phase range to see what data is good. If you select the phase threshold value equal to 0.3, then actually you are cutting all the unusable data and using the usable data for your calculation of phase noise. You can also detect the auto peak of your data. So you don't need to manually select the peak. If you just click the auto peak, then it will the code will be automatically able to detect the peak. So you have detected. You can see here that it's running and calculating the error in different wavelengths. If you look at the figure 13 and figure 14, you will see that it's changing. So we can detect the peak. So that is the final automatic peak detection that's required for our calculation. Now say we have selected our parameters. Now we want to save the data. We'll run our code to save the data. Say we are running to finally generating all the we are taking all the input and we'll finally generate the dispersion compensation file. So it's running to calculate. It's calculating the error. So you can see that from the figure 25 that error value is reducing over time. So our goal is to reduce the error after certain length. You can set that up. So this is our final data. Now if you wanna select that how much if you wanna select the dispersion compensation file, you have to input that where you wanna select. Say I wanna save the data over here. So I am copying that folder direction. So this is my dispersion compensation GUI. You have to put the directory, and if you click here and notice the command window. So you have basically selected here, you have given the saving location and selected here. Do you want to save the file? Yes, I want to save the file, and it will save the dispersion compensation file. And you can check that what are the data it saves. This is the dispersion compensation file. You can select the name. So we save this file. That's all about like how you can calculate the dispersion compensation and how can you use the dispersion compensation to calculate and you can apply this dispersion compensation. Like after dispersion compensation, you'll be, so this is the mirror peak, you'll be able to see the sharp peak because it's dispersion compensated data.